In this video, we're going to look at a logic problem that a friend sent me. In this problem, two logicians, A and B, each secretly pick a whole number from 1 to 30 inclusive. Each knows the other has done this, and then we have a couple statements here, and with these statements, we're supposed to deduce what number logician A has. In order to do this problem, I'm going to employ the use of sets to help us understand what's going on with each one of the statements. Since the statement "I don't know" appears a lot in this puzzle, I'm going to define specifically what "I don't know" means in terms of sets. "I don't know" is going to mean that both numbers A and B are part of the same set. This would mean that A could equal B, but A does not have to equal B, where A and B are numbers in the set. For example, imagine we were playing a game with a deck of cards, and you knew that the card that I was holding was a face card. If I were to ask you, are our cards the same, you could either say maybe or no. If the card you're holding is also a face card, there's a chance that we would have the same cards, and face card in our example here is the set of cards that we're pulling from. If you had a card that wasn't a face card, you could say no, because there would be no way that our cards are the same. With this in mind, let's start our problem. Let's define the number that logician A has as A and the number that logician B has as B. For both of these numbers, let A and B be an element of the set of integers from 1 to 30. The first question that logician A asks to B is your number double mine? Logician B says, I don't know. With how we've defined I don't know in terms of our sets, this means that if we have a set that contains 2A, it will also contain B. In this case, we have such a set, and this set we can obtain by just multiplying every number 1 through 30 by 2. So the set that contains both 2A and B is 2, 4, 6, 8, all the way up to 60. B is also in the set 1, 2, 3, all the way up to 30. So if we intersect those two sets, we get that B is an element of the set 2, 4, 6, 8, all the way up to 30, or just even numbers up to 30. Logician B then asks logician A the same question, is your number double mine? Logician A replies, I don't know. Using the same logic as before, we want to find a set that contains 2B. Since we just found a set that contains B, we can just double every element to find a set that contains 2B. This would be the set 4, 8, 12, or multiples of 4 up to 60. Since A is an element of the set 1, 2, 3, all the way up to 30, and the set of 4, 8, 12, all the way up to 60, we can take the intersection and find that A is in the set 4, 8, 12, all the way up to 28. Logician A then asks logician B, is your number half my number? B replies with, I don't know. Similarly as before, we want to find a set that contains 1/2 A. We just found a set that contains A, so we can have all the elements to find a set that contains 1/2 A. By one of our previous questions, we know that the set that contains B is even numbers up to 30, and the set that contains 1/2 A is even numbers up to 14. If we intersect the two, we find a new set that contains B. So B is in a set of even numbers up to 14. Logician B then asks logician A the same question. Is your number 1/2 my number. Logician A replies, I don't know. With similar logic, we want to find a set that contains 1/2 B since it will also include A. We just found a set that contains B, which is even numbers up through 14. So we can find a set that contains 1/2 B by just dividing each one of those numbers by 2. So this will be numbers 1 through 7. We also know from a previous problem that A was in the set of multiples of 4 up to 28. So we can now reduce the set that contains A by intersecting the numbers, the set 1 through 7, with the set of multiples of 4 up through 28. There's only one number that is in both those sets, and this is 4. Thus, logician B can say, I know your number, and conclude that logician A's number is 4. I thought this problem was a really fun problem, and I had a lot of fun solving it. I hope you enjoyed it as well. Thanks for watching.